Hey, today we're going to solve compound inequalities. Usually you will see them written like this. X plus 5 is less than 10, but x plus 5 is also greater than 1. To solve this, you kind of want to break everything up. What you want to do is you're actually going to do this part first. X plus 5 is greater than 10. X plus 5, is less than 10. Again, you're going to subtract 5 to both sides. Those cancel out. X is less than 5. So I'm going to go ahead and write x is less than 5. We go ahead and erase all of this. Now what I'm going to do is I'm going to undo this x plus 5, and now I'm going to do the other inequality. I'm going to do this inequality. 1 is less than x plus 5. Again, you're going to solve it just like we did in the past with solving one-step inequalities. Going to subtract 5 to both sides. Those cancel out. X is greater than 1 minus 5 is negative 4. So now I have negative 4 is less than x. I will go ahead and erase all of this, and let me show you how you go ahead and write this. So basically you're taking that x plus 5 and you're dividing into two separate inequalities. So now when you go to write this, what you're actually writing is x. I'm going to write this. X is greater than negative 4, but x is also less than 5. Less than 5. So when you go to graph this, negative 4, negative 3, negative 2, negative 1, here's 0, 1, 2, 3, 4, 5. Again, inequality sign, open circle, above 5, but x is less than 5, so our arrow is going to the left. But then my second part is negative 4 is less than x, or x is greater than negative 4. Again, open circle, but going to the left. So this line that connects negative 4 to negative 5, any number that falls on this number line in between negative 4 and 5 will make this statement true. So I'm going to pick 0. Let's put 0 in for x. Is 0 less than 5? Absolutely. Is 0 greater than negative 4? Absolutely. Therefore, this is true. Let's try another one. The next problem we're going to do is x minus 2 is greater than or equal to 4, but it's also less than 1. Again, let's go ahead and solve this side. X minus 2 greater than or equal to 4. Going to add 2 to both sides. X is greater than or equal to 6. So I will go ahead and write this over here. Now I will go ahead and do the other side. And once we get done with both sides, we will simplify the inequality, and then we will go ahead and graph it, and you will see something a little bit different than what we did on the other one. Now I'm going to do this side. 1 is greater than x minus 2. Again, I'm going to add 2 to both sides. X is actually less than 3. So 3 is greater than x. So let's go ahead and simplify this inequality. So we actually have x is greater than equal to 6, but I also have to write this one, x is less than 3. So when we go ahead and graph this, 3, 4, 5, 6, what I'm going to do is I'm going to graph x is greater than or equal to 6. Close circle, and again, x is greater than, bigger than, more than, which is why the arrow is going to the right. Now I'm going to go ahead and graph this one. 3 is greater than x, which means x has to be smaller than 3, because 3 is larger than that number. So again, it's going to be a closed circle, but but the arrow's going to the left, because x has to be smaller than 3. If you notice, there's no lines that intersect in between here. So what happens, since these two inequalities do not intersect, if I pick a number over here, let's say 10, and I put 10 in for here, 10 is greater than 6. However, 3 is not greater than 10. Now, if I go ahead and if I put a number in over here that's less than 3, let's say 0, 3 is greater than 0, however 0 is not greater than 6. So unfortunately for this, there is no solution to satisfy both of these inequalities, this one and this one. We are done for solving compound inequalities.